All right, 79, it says the number of people who have entered a museum on a certain day is modeled by a function f of t, where t is measured in hours since the museum opened that day. The number of people who have left the museum since it opened that same day is modeled by the function g of t. If f prime of t equals 380 times 1.02 to the t, and g prime of t equals 240 plus 240 sine of pi times t minus 4 over 12, at what time t for t between 1 and 11 is the number of people in the museum at a maximum? All right, so we just got to think, conceptually. So let's make a new equation, n of t, to represent just the number of people in the museum at any time t, n of t. So then n of t would be the number of people who entered the museum minus the number of people who left the museum at that up to that time. So you can think of n of t as being equal to f of t minus g of t. Now, we're given the derivatives of f of t and g of t, and we want to figure out when is the number of people in the museum at a max. So one way to go about this is essentially to recognize that the maximum number of people in the museum will occur at the basically when the derivative, we can study the derivative of n of t and look to see where it reaches its max value of increasing, like where it increases the most, like at what point. In other words, if we find n prime of t, n prime of t would be f prime of t minus g prime of t. So let's just graph this, and let me show you what we can say about the graph. So n prime of t equals f prime of t. So we're using graphing calculator. So just entering this in your calculator. So let me see. Okay, so I get something like this. So let me see. Okay, so let me zoom out of this so we can see a little better. Wow. Okay, so zoom out. I don't know if we need to zoom out even anymore. Ooh. Well, anyways, so this is showing n prime of t. This is showing how the number of people in the museum is changing. So you can see that it's increasing all the way up to this point, because essentially, if we're studying the graph of n prime of t, then the number of people in the museum will continue to increase as long as n prime of t is positive. So for example, let me just draw a sketch here. So n prime of t, it does something like this. And since we're only studying up to t equals 11, so the maximum number of people will occur at this point, because all the way up to here, the number of people in the museum increase because n prime of t is positive. After this point, it decreases because n prime of t is negative. So let's find where that 0 is. You can see it's about 7.88. 888. So it's going to reach its maximum number of people at 7.888 hours after it opens. So the answer is B. 80. The derivative of the function f is continuous on the closed interval 0 to 4. Values of f and f prime for selected values of x are given in the table above. If the integral from 0 to 4 of f prime of t dt equals 8, then f of 4 equals. Okay, so for this, we can set up a simple equation. As long as you recognize that if you have the integral of f prime of t from 0 to 4, integrating this essentially takes the antiderivative of f prime of t, which is f of t. So this will be equal to f of 4 minus f of 0 using the fundamental theorem of calculus. Now, we're told the integral from 0 to 4 is 8, so we can set 8 equal to f of 4. And we're given that f of 0 is 5. So we can just solve this equation. I penciled in there. We can solve this equation for just f of 4. You just add 5 to both sides. We get 13 equals f of 4. And so the answer is E. Right, 81. The slope field for a differential equation is shown in the figure above. If y equals f of x is the particular solution to the differential equation, this is the point. -1, 2, and h of x equals 3x times f of x, then h prime of -1 equals. Well, okay, well, you just got to find the derivative of this by using the product rule. So in general, if we took h prime of x, we want to find the derivative of that, of this. We take the derivative of 3x, which is 3 times f of x, plus 3x times f prime of x, using the product rule. Now, if we want to find f prime at a specific point, so at x equals -1, we just replace all the x's with -1. So h prime of -1 will be equal to 3 times f of -1 plus 3 times -1 times f prime of -1. So 3 times f of -1 f of -1 would be, let's see. Oh, well, right, doing right here, it's negative is equal to 2. F of -1 is equal to 2. So 3 times 2 plus 3 times -1, so plus -3 times f prime of -1. So we look at what's going on at -1. And since we're looking at, since the particular solution is this point over here, we look at the slope over here, because f prime of -1 is basically the slope of this tangent line, which looks like to be -2 over 1, so -2. So we get 6 plus 6, essentially. We get 6 plus 6. So the answer is 12, or E. 82, if f is continuous, if f is a continuous function such that f of t equals 6, which of the following statements must be true? Okay, so this is just, checking that you know your limit properties of functions. So this won't really be too rigorously tested. You only have to know a couple of them, which are pretty kind of logical, but let's see. So wouldn't be A, wouldn't make sense because you're taking twice the endpoint. Yeah, that'll be like a composite. So it's not gonna be A. Limit of as x approaches 2 of f of 2. No, that I don't even know if they're getting that there. we want to see where we can essentially find f of 2. Where can we plug f of 2 in easily? Nothing like this. So so here is just see we have the f of x isolated. So in there we just put in the f of 2 is equal to 6. So 6 squared, 36. So we're taking f of 2. And so the answer is simply E.